In this video, I'm going to do our first formal geometric construction. I am going to draw a perfect equilateral triangle given one side using a compass and a ruler. But I'm not going to draw any circles and I'm not going to do any measuring. And you may be turning to the person next to you at this point and saying, wait, isn't that what compasses and rulers are for? Well, we'll see. First, I want to give you another riddle, which is this. Here is a circle. What is it about a circle that makes that shape so recognizable? You may have been taught that a circle is just what this shape is, and you're really good at this point of recognizing things that are circles and things that are not circles. But what's the key feature about circles that makes them so special and so important in our world? Well, I've had people tell me that the important thing is that a circle doesn't have any straight edges. And that's true. Triangles and squares and rectangles and other shapes like that are made up of straight edges, and there are no straight edges in a circle. But an egg shape is also not a circle, but it doesn't have any straight edges either. So that isn't quite the definition of what makes circles special. And the answer to the question is that the special thing about circles is that if you take the center and take any point on the boundary of the circle and measure it, you're always going to get the same distance. Every point on the circle is the same distance from the center. All right, and that's what makes compasses so valuable. If all they did was draw circles, that'd be a fun little toy. But the reason we use them in geometry is because they're doing something fundamentally more important. If I open up this to a certain distance, and let's say I measured this and found out that this was 2 inches or something like that, what I would be able to do is if I didn't wobble my compass, and if I plopped down my pointy end and didn't move it, everywhere the pencil marks on the paper is that same 3 inches away from the pointy end. So that's going to be a really important and valuable concept for us moving forward. Let's take a look at that equilateral triangle that we want to draw. So I've got these 2 points, A and B. Just to make the conversation easier, they are 4 inches apart. So what I'm going to do, this would work whether they're 4 inches apart or 3.5 inches apart or any distance at all. I'm just going to use 4 inches just so it can make our conversation easier. So I've got my compass opened to measure the distance of that line segment. And now I'm going to plunk the pointy end down on A, and I'm going to draw an arc up here. And remember what I just said a minute ago. Every point in this arc is 4 inches away from A. I know that because the pointy end was staying on A when I drew that arc, and the compass didn't open or close any when I was drawing that. So every one of those points is 4 inches away from A. Now I'm going to do the same thing, except I'm going to have my pointy end on B. And once again, I'm going to draw an arc. And what's true of every point on this second arc? Well, every point on that second arc is 4 inches away from B. So my goal was to create an equilateral triangle. An equilateral triangle is a triangle where all 3 sides are congruent. So I've got A and B being 4 inches away from each other. So where can I find a point on this page that's 4 inches away from A and also 4 inches away from B? Well, give yourself a gold star if you said, well, it's where these 2 arcs meet. Because every point on this arc is 4 inches from A, and every point on this arc is 4 inches from B. So where they meet Since it's on both of those arcs, it must be 4 inches away from both of them. So I can mark this point, I can call it C. And now I'm going to use my ruler, but I'm not using it to measure anything. I'm just using it to draw the straight line from C to A and from C to B. This was the rule that the ancient Greeks came up with when they were doing constructions. They were using a compass, and they used what they were called a straight edge. So a straight edge didn't have any markings on it at all. And so I'm going to tell you that that's an equilateral triangle there. How can I prove it to you? Again, I could get the ruler, but let's use the compass. So this is the distance between A and B. This is the distance between A and C. And this is the distance between B and C. So I can use my compass as a tool to tell you that line segments are congruent just by measuring both of them without opening or closing the compass any. So there's our first construction, making an equilateral triangle given one side of it. So take your own ruler and compass and see if you can duplicate that effort. It might take you a little practice because when you're starting to use a compass, you might be a little bit more wobbly. You might, find yourself opening the compass a little bit more than you intended. But if you measure the distance as 4 inches, if you wanted to, you can come and measure when you're done. See, that's also 4 inches, and that's also 4 inches. So this gives you an idea of how we can do constructions using a tool that makes circles and a tool that we're not going to use for measuring, even though we always have in our lives.